Hi ladies! So here's the second part of our calorimeter experiment. This is where we're actually going to do the chemical reactions. So in the other video we calibrated the calorimeter, so I'm using exactly the same calorimeter and it will link into this experiment. So this experiment says to determine energy changes in various chemical reactions using a calibrated calorimeter. There's going to be 3 experiments. So a reaction between magnesium and hydrochloric acid, reaction between hydrochloric acid and sodium hydroxide, and the dissolution of potassium nitrate. We just have to note down the highest or lowest, depending on whether it's exothermic or endothermic temperature that it reaches. So we don't actually have to time this one. Okay, and then there's some questions. Okay, so I've just measured out the 2 chemicals that you'll be requiring. So I've got my 100 ml of hydrochloric acid. I do need to put that in the calorimeter and allow the temperature to settle. The other chemical we're placing in is the magnesium powder. Now this is the experiment where I said, the student put in 2 grams instead of 0.2. Now the actual mass of this, which you'll need to record, it's 0.24 gram, because we had a range. We could go between 0.2 and 0.25. So the mass of the magnesium is 0.24 grams. So what I need to do is I need to stir that until there's a constant temperature. So we'll just wait a few minutes and see if the temperature changes. Okay, if you can record that temperature, and now I'm going to add the magnesium. So I'll stir it until we reach our highest temperature. If you want to know the observation, it's already started producing a gas. So there was gas coming out of it, there was heat, it was fizzing, it was bubbling. Endo or exo? I wonder. Okay, it's starting to slow down, it's dropping now. So where was the highest? Oh no, interesting. I better keep stirring. I think that's because when I'm stirring, hang on, I haven't kept it uniformed. Naughty me. So what was the highest that we got up to? Alright, so what was the highest temperature that we got to for that reaction? So that was the hydrochloric acid and the magnesium. It'll start going back up now because I've stopped stirring it. But as soon as I start, so record that top one that you got. Okay, so 50 mils of the hydrochloric acid is going into the calorimeter, and then we need the temperature to settle. Now all these chemicals have been sitting out in the science room, so they're not going to take long to reach a constant temp. Well, actually, they're probably not going to change at all. Okay, so at the moment I've only got the 50 mils of hydrochloric acid. Might change up my characters and then I'm doing different experiments. Alright, so this is the acid and the base one. Oh, my Penny's a bit too... There, Penny's got her eye on it. Watch out. Alright. Now the other thing I needed to do was I needed to measure the temperature of the sodium hydroxide. So I've got the bulb sitting in the liquid. You can see the scale. There's a 10, there's a 20. So what temperature are we sitting on? Sodium hydroxide. What temp? Your hydrochloric acid should be theoretically around about the same temperature. It's a little bit higher, but the thermometer may not be calibrated properly. Okay, so hopefully you've got those two temperatures down. I'm not recording anything, so you'll need to make sure that you're recording the temperatures. I'm going to add the sodium hydroxide, a strong base, to hydrochloric acid, which is a strong acid. 50 ml of each. I can already smell some gas being produced. What do you think the gas might be? Here we go. Better zoom out a bit. Remember, looking for the highest temperature reached. Come on, Penny. Keep an eye on it. Increasing. Is it dropping? Okay, I'd say that's probably about all we're going to get on that one. All right, thanks, Penny, the platypus, for helping out. Okay, so the third and final experiment is the dissolution of potassium nitrate. What that means is basically the dissolving of potassium nitrate. So it'll go from KNO3 as a solid. If you were going to draw the reaction, you would have the water over the arrow because it doesn't actually act as a reactant. It just allows the ions to separate. So you end up with K plus aqueous plus NO3 negative aqueous. It does give a bit of a hint because it says the lowest steady temperature. So have a think maybe what type of reaction this might be. I've got Snowy, the snow leopard, helping out now on the third one. So I've added the water, the 100 ml of water into the calorimeter, just waiting for the temperature to become constant. Once again, I used distilled water, so it was sitting in the science room, so it should be pretty constant anyway. I can't see that it's really going to change much. So we'll just give it a little bit of time. Okay, I had to weigh out about accurately 3 grams of potassium nitrate. I've done that here. Okay, we can see temperature. I'll probably zoom in a little bit more when we get going. Well, actually, I might as well do it now. Just to point out, this is 10, this is 0. All right, let's get that going. Let's stir so we can have a uniform temperature in the calorimeter. Are we noticing anything? That's it, girls. Wasn't a huge change. Might as well record that temperature now. So that's the 3 reactions done. You'll need to answer the rest of the questions and put a conclusion. Now, don't worry about an evaluation because I did the experiment. You can type it up if you like, except there are calculations and I need to see all your working out. So I'd say it's going to be easier to handwrite it because you've got those energy calculations. Would be a good idea to get this experiment completed and written up before the SAC, okay, because it will contain similar calculations. Big thank you to my assistants. This is probably their last video that they'll be. Big thank you to Snowy, the snow leopard. Thank you to my 3 amigos, Tilly the tiger, Billy the bilby, and Penny the platypus. And massive thank you to a supporter I've had since Remote Learning 1.0. Pretty experienced now in the whole remote learning thing. Professor Bones. Thanks, Professor Bones. Starting to lose your safety glasses there, mate. Might need to fix them up. All right, see you later, girls. Bye.